And welcome to today's daily Leetcode challenge. This is going to be question 547, number of provinces. There are n cities, some of them are connected, while some are not. If city A is connected directly to city B and city B is connected directly to city C, then city A is connected indirectly with city C, the transitive property. A province is a group of directly or indirectly connected cities. No other city outside of this group. You are given an n by n matrix is connected, where is connected ij is equal to 1 if city I and city j are cities directly connected, and is connected ij equals 0 otherwise. Return the total number of provinces. And we're given a couple of examples. So this is a 3 by 3 matrix of is connected, and it seems like cities 1 and 2 are connected while 3 is left out. And in a matrix, that would be 1 is connected to 1, 1 is connected to 2, 1 is not connected to 3, 2 is connected to 1, 2 is connected to 2, 2 is not connected to 3, 3 is not connected to 1, 3 is not connected to 2, 3 is connected to 3. And the output is 2 provinces. In a situation where it is when there's 3 provinces and 3 cities, it would mean that provinces are just comprised of 1 city, and so that's just the identity matrix, 1, 1, 1 diagonally. And constraints seem to indicate that the matrix can be pretty large, but nothing too crazy. And the content of that matrix is 1 or 0. Is connected equals 1. I'm not sure what that means. Oh. Okay. And this is just saying that ij is the same as ji. Okay. Well, what do I think right off the bat? I'm thinking that we need a way to, as fast as possible, identify the groups in which these cities will be, right? I'm thinking of union find right off the bat. That seems like in one pass of all the cities, we could have a data structure, union find, that will identify which cities are connected to which groups, and we could modify the union command slightly to indicate that it belongs to basically update the total number of cities currently, the total number of provinces. So in the case where in union we are connecting two provinces that have previously not been connected, we decrease the number of provinces by 1. Let's try this as the first iteration of success. We have a union find. We have the num provinces. Let's have that be the length of is connected, which is just the maximum number of cities. And let's have our find, which takes in a node and says, and we say that if union find of n is equal to n, so if it's equal to itself, then return n, meaning that we have found the parent node, else return find of union find of n. And then we have the union command, connecting m and n and m, where we first find the n parent, find n, then we find the m parent, can't type today, find m. And here, in a traditional union find, we would simply reassign the parent of either m or n to parent m or n. Here, however, I want to make a slight modification. We've previously identified that the number of let's actually have this like this. We've previously identified that the number of provinces is equal to n. So we can say here that if np does not equal mp, that would show that we are currently connecting a province to potentially another province, or a city to another province. Thereby, we would have to decrement the number of total provinces. And finally, union, do the standard linkage of the two subgroups. We're going to choose MP as the one that will inherit the MP. And let's see, we have pretty much this whole thing set up. Let me see one thing. I do have to pre-populate union find with elements indicating whose parent each of the nodes is. And for starters, that's just going to be itself. So it's going to be I for I in range. And let's have this guy over here in range n. And this is our union find. Let's see if we have, okay, so now for our approach to populating this, we know that we're returning num of provinces, but how do we identify all of them? Well, for city in range of n, we need to sort of okay, we have the is connected matrix, and we need to, for each node, for each city, we need to look at the corresponding is connected array, and for connected cities we need to union them. So we have a city for range in IM, we have its neighbors. So now we're going to say that for, let's call this for neighbor in is connected of I, the city that we're currently looking at, if neighbor is equal to 1, meaning that it is connected, we're going to union I, the current city, with the neighbor. The exception here is we also potentially don't want to union ourselves, although we also don't want to union ourselves. So if, and actually, since it's a matrix, symmetrical matrix along the diagonal, what if we just don't go, what if we just look at one side of this matrix, right? So for I in range, what if I say for j in range I, meaning that the first element is never going to, this is so much better. So now I have the two cities, I and j, and this is pretty much scene print I, j. We should have, we should see that we get 0, 1, no, 1, 0, 2, 0, 2, 1. Perfect. Those, this one essentially, and these two. These are the these are all the information that we need. That 2 is actually connected to 1, and 3 is not connected to 1 or 2. So now that we have this, what is our one concern? Our concern is that if is connected of I and j equals to 1, then do the union. Then do the union. Okay, let's see if this works. Union is not defined. Onion. And this should... Sorry, what? Neighbor is not defined. I and j, I meant. Union of I and j. Okay, and number of provinces is non-local. So let's actually, yeah, this is a common thing. Local num provinces. And should we also get union find in there? That is, sorry. Okay. So we're actually not beating a lot of people. Let's see if there's some faster solutions. Cane range. So there's a DFS solution. Let's think of how a DFS approach could work, because that seems to be the... No, union find is also a solution that's fast. DFS, however, let's see what is DFS. DFS is an ability to search through the whole graph, essentially all of the connected nodes, and potentially fill out something called a visited array. As we are visiting the array, we could be adjusting what we for example, okay, let's say that we are we're a DFS approach to this problem. We start our search at the first city. If our first city has any connected cities to it, we could pre-fill the visited array with the cities that city 1 is connected to. As we fill out these cities, which would be 1 and 2, we all of a sudden, on the next iteration of the DFS, when we're looking at the second city, can say that, well, actually, we've already hit city 2 in the previous DFS traversal, in the previous search. So let's say that we're not including this as part of the group. As we hit the third city, we see that it has not been visited, so we would increment the number of groups that we have encountered. So that would be 2. Let's try quickly doing that. I want to see if the DFS approach could reap some benefits. Visited false for in range. Let's have the n right here, and len of is connected, and let's have the number of num of provinces be equal to 0 right off the bat, and have a DFS array where we look at one of our cities. How would DFS here work? Well, a DFS, we want to recursively look through all of its current neighboring cities. So what would that be? For neighbor in is connected of n, and this already being the neighbors. Okay, so I need the number of the city, as well the index of the city, as well as whether it is connected or not. So let's enumerate this. Enumeration gives us the index and the value itself. So the enumeration in this case is the actual index, and the connected is going to be the 1 or 0. So for neighbor and connected, if connected, we want to DFS on the neighbor. If it's connected, we want to DFS on the neighbor. If connected and maybe and not visited of neighbor, right? Because if it's already been visited, then we're not going to connect it. Here, if we have already DFS'd current node and we're in this function, then we're going to call visited of n to true. Let's see, visited. Okay, that's all there. I'm just getting confused. So visited is true for neighbor and connected, and enumerate current neighbors. If connected and not visited, then do DFS. DFS. If not visited. Okay, perfect. Let us now see. So the number of provinces is initially going to be 0, and we are returning the number of provinces. But how do we iterate over all of them, right? So for city in range n, starting with 0, ending with 1, if visited, if not visited, city, initially it's not going to be visited. We're going to increase the number of provinces by 1, and we're going to DFS city. Okay, this could be a little bit cleaner. Here's my explanation of why DFS is a cleaner solution. What union find allows us to do during the process of unioning connected cities is it also gives us additional information. That additional information is which group does this node belong to, and which node does city A belong to, which node does city B belong to. There's an additional complication with that, and that comes in the form of, previously in the form of the union find array, where we could essentially reconstruct which groups are connected to which other groups. Here, the approach is simplified. We no longer care, and we no longer care to store information about which city belongs to which group. We're just worried about sort of iterating through the graph and making sure that we don't encounter the same group more than once, right? So as soon as we hit a single group here, in the process of looking at first city 1, 0, and so on, as soon as we hit city 1, 0, we look through all the other groups. We look through all the other cities in that group, and we populate this visited array with true values for been visited. So as the next time we hit a city that's not part of that group would be the next time that we iterate number of provinces. Let's submit this and see if we are successful. And we're a little bit faster, still not significantly faster than everything else. Let's see what they're doing. DFS, range, not visited, count. So all the same approach as DFS for and not visited DFS. This is 1-to-1 to what I have. So maybe they populate the visited array initially faster. Let's try doing something about this. I don't know why. Times n, visited true. They don't do the enumeration, but that shouldn't do anything. Submit this one more time. I'm just really wondering if there's a significant speed bump. Okay, no, it seems like maybe it's just lingering code like different implementations leading to slightly different runtimes. I would probably say that this is the better solution. Don't use the union find because it gets confusing. You're using union find for a slightly different purpose. And perfect. Okay, well, thanks for watching. Please like and subscribe. I'm going to start uploading videos daily. And with that, thank you. Bye.